Let's design a system today that identifies like trending topics on uh, we can we can call it Twitter, I guess. Yeah.
Okay, cool. So I kind of have like a loose framework of just the big talking points for system design. Like probably gonna I want to go through the requirements, and then after that, maybe go through some back of the envelope, and then do talk about the data modeling and the API.
Great. Sounds good.
And,
And you can use any like tool you want if you want to draw stuff, if you want to write stuff, if you just want to talk, anything's cool with me. So
okay. Um, I might just talk. I might have like my notes here to
yeah,
help guide my own thinking, but I'll probably just talk if that's fine.
sounds good. Yeah, totally.
Okay. So we want to build a system in order to track trending topics on Twitter.
Yeah, exactly.
And is this kind of like a passive system wherein we have to read tweets that are live or historical tweets, or will other systems be submitting some metadata to us?
So we need to be we have a Twitter kind of like already set up where we can post tweets and they get written to a database, and some business logic might happen. But so far, there's no ingesting, there's no kind of cross connection with any other services. So it's up to us to figure out how we want to ingest as close to real time as possible, what tweets are being tweeted. And then basically what we want to create at the end of the day is like an endpoint that when we go to the trending tab on our app,
Yeah,
it gives us stuff that is relevant to us and pretty up to date.
gotcha. Okay. Um, are there any requirements on the latency of
Mm.
the service or?
It's not like real time, like finance real time, but it certainly should have like within a minute or less.
Okay, like we don't want to do like nightly batch processing or something.
No, no, it has to be like in the last hour, someone tweeted something crazy, and I want to be able to go to the trending section and see that. Or if there's a mass catastrophe, I should be able to see that as well.
Okay. See that as a topic, just to clarify, not necessarily the tweets themselves.
Right, and we can. It's sort of up to you how you want to think about that. Like if it's based on a hashtag that's a trending hashtag, or is it about a topic that people are writing about that's more kind of loose? Um, Up to you.
Okay. Um, Something I want to think about and do, I think, is maybe separate out. So I think we definitely want we want our service to index on keywords,
Mhm.
but I think maybe we can consider keyword extraction from the tweets kind of like a separate service.
Yep.
And
Makes
then so by the time we start our work, we just have a bunch of keywords. Um,
sense. Yeah.
and so, okay, so back of the envelope is just going to be kind of like, so our main data type is going to be strings probably.
Hmm.
Um, do we have any numbers with regards to like the volume of tweets that we're receiving?
So let's say it's at Twitter scale, like so on the order of millions of tweets per probably hour. And so it's pretty high scale. We can start like if you want to simplify it in the beginning, that's totally fine. But I would love to get into how you would scale it at some point. And then there's also the concern of like what's trending in China is probably not what's trending in the United States. So there's like let's say that everyone speaks English, by the way. So like let's just get rid of that whole element. But
Yeah.
we do want some sort of conditional trending based on your demographic, geolocation.
Oh, interesting. Okay. So the output of our system would not be a single trending list, but we want to have multiple trending lists.
Right. So maybe like you take in like a geolocation and some other information, and then it returns a trending list.
I see. Okay, maybe we can get into that when we talk about the data model.
Great.
Um, but okay. And then, yeah, I guess standardizing on English is a good one. It'll make things a little easier. So typically for back of the envelope, it's just some stoichiometry. So if we have like millions of tweets an hour, and then we assume 5 keywords per tweet, let's say. So we have 5 million strings per hour. And then if we say each string is like, I don't know, 10 characters, let's say.
Sure.
So we have 50 million characters. Um, and the character is like 8 bytes.
Right.
So I would bust out my calculator and then just say that that's 45 times 40, 400 million bytes. And so probably somewhere in the order of like, let's say kilobyte is 10 to the third. Um, megabyte is 10 to the sixth. Uh, okay, so about 400 megabytes.
Yep.
Okay, per hour. So in a day times 24 is going to be like, if we do just times 20, that's 400, 800, and 8,000 megabytes per hour.
Per day. Right.
Yeah.
Yeah.
So that's probably 8 gigs per day, sounds like. And
Yep.
then how long would we be storing these keywords? Probably
Yeah.
as long as we're storing the tweets.
Yeah. I think that maybe you can go into like some cold storage. Like it doesn't need to be like kind of live. Like there's not some search functionality where you can see what was trending last week, but we can say that as long as something is trending, it should be like in our primary store.
Okay. So we've got like, so if we're considering a day or even like 2 days worth of data, we're looking at like 16 gigabytes. Let's just say. I didn't actually bust out a calculator, so.
You're right. I guess there's the one concern of like now that it's like geolocation too, it's not just like strings, but also like metadata about where it was tweeted and by who, or yeah.
True.
But with the string part, I think that's spot on.
Okay. Yeah, I mean, because what I'm thinking about is, oh, so just to close this out, 16 gigabytes. And so I feel like that's definitely doable as far as storage is concerned. And as far as memory is concerned, that's still not unheard of. That's like you could easily rent hosts that have that much memory.
Yeah.
But if not, we can like process it in like a batch or something.
Right. Right.
Okay. But then moving on to like our data model. Um, so I was thinking of, so we've been talking about the location as like an aggregation data point, but I think it would be kind of cool if our service could just support general aggregations. So sure, you want to aggregate by geo for say, let's say, and then um, come up with a ranking, or you could also do it by, like you said, by user metadata. And so I think this directly impacts our back of the envelope. Um, so, but I mean, that could probably just be strings, and we don't have to roll out. Well, we can build the system in anticipation of these generalized aggregations, but we can probably launch with like 2 to 3 types of aggregations.
Yeah, can you give me an example of like another type of aggregation you're thinking about?
Yeah. So one would be like country, I guess,
Mm,
as we've been talking about. Then another could be an age bracket.
sure.
Uh,
Yeah.
Others could be like zip codes, maybe if it's in the U.S. or if the country supports zip codes.
Or like political preferences or something like that.
Yeah.
Yeah.
Political preferences or like follower counts or
Mm,
tweet counts, maybe because you want to why bother with outliers, I guess, because there's probably specific whales in the system that we particularly want to pay attention to.
yeah. Yeah. Cool. Yeah. So let's say that we want to build for aggregates in mind. But for now, the only ones we care about are like this trending time window. So aggregating tweets by maybe some sliding amount, and then geolocation.
Um, okay, so we talked a bit about the data model and then the API. Initially, we can just say like submit keywords, submit keyword, and then that would count as a submission of a keyword and then the associated metadata. And then the system would just ingest that. And then um, another API could be get trending, and then you provide it like a aggregation object or filter, so to speak, and then it'll go through all the keywords that were submitted to it.
Yeah, I like that.
Okay. And then so moving on to components, I guess it kind of dovetails if we have a pretty clear requirement for geolocation, we could have our system run. We could distribute our system globally, and I think at least initially for launch, the consistency and replication across locations is kind of not really something we have to worry about. And so what I mean is if we deploy our system to, let's say, America, Europe, and Asia, it's like you can't really, those three systems have minimal communication because they have their own excluded.
Mm.
Um,
So you're thinking of like having separate instances of the service based on your location. So then,
yeah.
okay, interesting. Yeah.
And then, of course, this will kind of break when, if you want to support globally
Right.
scoped. Yeah. But then, um, I think even with it's not really a one-way door. We can always still have that and just build on top of our regional
What would that
system.
look like?
Come again?
What would that look like? Like if we
Um,
wanted to support global trends.
so naively speaking, like you could probably just have you could create like a new system like which is a globalized system, which basically thinks in terms of like, okay, let me aggregate the aggregates, and so it would query all of the other systems and get their localized trending topics as well
Mm.
as the metadata, and then so that it has something to compare these trending items against each other. Um, or we could just query those systems for their raw data, like the raw um, keywords that were submitted to them, so that as if it was submitted to us, so to speak. Or they could also in the background be submitting it to this global service. And then where that runs is kind of TBD because I know like there's like snowflakes, right? Like there's GDPR, where in some
Right.
continents are kind of like their data cannot leave there, and so it would be tricky because um, we'd have to have two globalized systems, maybe one that's dedicatedly running just in Europe, and then another one that's running like on U.S. soil or something.
Mm. Yeah, let's ignore the hairy and terrible problems of like compliance and regulation at this point.
Okay,
Yeah.
cool. So, okay, so with that being said, are we okay moving forward with just this like regionalized or yeah, this geo-distributed system?
Yeah, I think it definitely simplifies the data model for the like geographical trending topics. I think that like if you were trying to get more granular about like yes, you've one instance that's running in Asia, but then if you want to see what's trending in Beijing, that's going to be tricky as well. And then it just seems like a sort of the same problem as when we want global trending topics, but we only have the regional ones. Now we need like many local instances and then like sum them into like a Asia one.
Right.
I don't know, but yeah, would love to like think through that. Like
Like
how
a
you think about city based or zip code as you mentioned. Um, like yeah,
so yeah, so I mean, in all of these three systems between America, Asia, and Europe, it would still be the same, largely the same source code, maybe with different runtime configurations, but it's largely the same source code. It would just be that the keywords that are submitted to us will have different metadata associated with it. So the Asia service might still will still definitely be able to drill down and provide. From what I can tell, it could still be able to drill down and provide um, finer granularity in terms of aggregation. Like we
Mhm.
could still provide aggregation filters that will aggregate by zip code or city or
Sure.
province name, or maybe even like across within a radius of
Yeah.
something.
Yeah. Okay.
Um, and then
And with that in mind, then I'd love to dive into like yeah the how that would work. Um,
okay, so one question I forgot to ask was, do we anticipate there's probably going to be like what type of read write ratio should we be thinking about? Would it be kind of equal or would it be heavily? I mean, it's definitely going to be heavily write. We talked about that.
it seems like it. I mean, when I'm thinking of my own Twitter usage, I definitely read a lot more tweets than I write. Um, but I mean, it's reading and writing from different systems, right? In your architecture, like I'm probably only navigating to the trending page like once
Hmm.
per session. So we could call that like a read of our new endpoint. But I don't know if you want to think about trending as the number of reads of a tweet or how you want to think about that element, because then it becomes more complicated. But like it's not just retweets and likes on a tweet. It's like reads. But for now, I let's say just for simplicity, we can say it's like pretty balanced maybe between reads and writes.
Okay, so it's balanced. Okay, and another thing that I realized is for reads, I think we can pretty sensibly protect the system and still meet the requirements by caching the results. Because
Mhm.
what was trending, let's say 5 minutes ago, is probably still trending now,
Yeah.
uh,
Yeah.
and we can just publish new trending lists periodically, like multiple times in the hour, and then the clients would be able to just check for that.
Definitely. Yeah, I think that's a good idea.
Okay. Um, and then so I'm thinking we could have the application servers, we could have databases that they connect to. We can have this is kind of weird to do with a whiteboard, but we could have some load balancers in front of the application to receive the keyword submissions, and then um, we could definitely have a caching load balancer, like totally different DNS name for um, reading the trending topics, and then yeah, okay.
Makes
And
sense.
so keywords will be submitted, it'll be processed, and
Yeah, what does that aggregation or processing look like?
right. So it would be naively like the most straightforward thing is take a keyword along with its metadata and then shove it in a database. Um, and then whenever it's time, like maybe we have a periodic job that would read all of these keywords from the databases, including their metadata, not necessarily onto one host, but it could create a task that it distributes across many hosts. And then all those hosts, start funneling their results together. And then we output um, a trending list that could be served and cached by the read part of the house. Um,
So is there like a query that we're running on this database that like queries for the last 5 minutes of timestamps tweets and then like buckets them into the keywords and just like picks the top and or keywords that are mentioned, or like how are you
yeah,
thinking of that?
that's what I'm thinking. Like um, initially, I was just thinking it would be like you would be a certain keyword would be trending based on the number of tweets that have that keyword.
Yeah, is there
Um,
like a data structure that like you can think of that would be particularly well suited to this, like if we went beyond a database, it's like a normal SQL database?
um,
It's not like trivia. Like I'm just trying to think of like what are we trying to do here, and like yeah, just because it seems like if we do a query through every keyword and then count it up, and it just seems expensive.
yes, yeah. Like I think what would have to happen is like we would have to partition the data, like partition the rows, and then only some worker hosts would be responsible for reading some of the rows so that they don't double count. And then they would read in the rows and aggregate and then submit those aggregations to maybe another table
Mm.
and line it up or associate it with a task ID. And then other jobs would be to take all those task IDs and produce like a total output. Um, but thinking about data structures, like I think, like I know Redis supports counted sets, for example. So if for whatever reason we would want to use that rather than and basically make requests to Redis and say count, 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 count every time we come across a row, rather than doing that in memory and then putting it back in a SQL database. Um, and then when it comes to if we have like a limit of us wanting to show like the top 500 trending keywords, let's say, rather than all of them. Um, because if you looked at the distribution, there's probably like a skew, like it's all going to be
Yeah,
bunched up massive on one end and then 10 mentions for everything else for a million other keywords. And
right.
so you probably have to establish some cap. But let's say we just statically say 500. Um, I could think of like, yeah, just making a query with a limit on it,
Yep. Yeah.
or yeah, or we could use like a heap maybe to kind of keep track, a fixed size heap to keep track of the maximum number of um, the top 500.
Yeah.
Uh,
Cool.
and
Yeah, I
then,
was thinking about a heap, and then I was like, the heap is like in memory. Like I don't even know how I would do that with like a big uh
and
like
like, so I know that there's this like a friend sent me this obscure white paper, but I never really chewed through the whole thing. But essentially, it was like, it was a way, so it's used in networking
Mhm.
because there's this concept of top talkers in networks. But of
Right.
course, what that means is like, who are the top like senders of packets as well as receivers. which of course, like in a big network, is like could be hundreds of thousands, if not millions, from the perspective of a single router. But yeah, there's some data structure that can receive like just atomic
Hmm.
updates, and then it can keep like a top 200, top 300 list.
Makes sense. Yeah.
Cool.